So I'm pretty sure that these first three diagrams, including this one that you see, are available on a sheet that I photocopied in your booklet number 1 supplemental thing that I attached I think it's a blue sheet to. If not, sorry, you have it here. It's probably printable. Or you can generally put down what we need to for the characteristics. So, the characteristics can be given to you in visual form this way, as in graphical, or I can just list the criteria, which I think I do later on in this note. So this question says state the equation of the polynomial function. So a reminder that when somebody specifically asks you for a polynomial function, you have to start with either f of x equals or y equals. So that's got to be our therefore statement containing that information. What I have to do to make the polynomial function equation, and it doesn't say whether it's in standard form or in factored form, so I'm going to go for factored form. We need to find all the x-intercepts, and we need to find the y-intercept. So I've color-coded them. The x-intercepts, and I'm going to list them on the up and down. This one, this is -2, so that's -1. This one is 1. This one's 2. This one's 3. This goes straight through, this goes straight through, this goes straight through, this goes straight through. So they're not, there's no double roots and points of inflection. So all of these are order 1. Then, to continue my color coding, the y-intercept is -6. Now, I will come back to that. The first thing you have to deal with is the fact that you have these. So you've got to take this backwards and make the brackets. So what I mean by that is you will have a bracket of x plus 1 that the x-intercept of -1 came from. And you will have a bracket of x minus 1 where this one came from. And you'll have a bracket of x minus 2 where x-intercept of 2 came from. And you'll have a bracket of x minus 3 where the x-intercept of 3 came from. So all the reverses of those. But that doesn't take into account this. So what you need to do, and you can use f at x or y, I'm going to use y just for space. You have to have y equals and then possibly a number out front. We're not 100% sure what that number is, but there might be a number. And if there isn't a number, it's still a number because it'll be the number 1. So you got to make sure that something is filling that spot. It's definitely not a 0 because 0 times all of this is 0, and then you wouldn't have this picture. So back to the y-intercept for a second. The y-intercept is a y value and your x value is 0. So I'm going to turn all my x's into 0 and all my y's, all one of them, into -6. So -6 equals, don't know what a is, 0 plus 1, 0 minus 1, 0 minus 2, 0 minus 3. Figure out each of the brackets. So that's 1 times -1 times -2 times -3. So I can multiply all my numbers together on the right-hand side. So -1, -1 times +6 is -6a. We're trying to solve for a. So we have to get the a by itself, so divide out the -6, and we get an a of 1. So that means, number 1, the exact equation is y equals x plus 1 times x minus 1 times x minus 2 times x minus 3, with or without the visible 1 in. And just to specify, that thing we made before we did all the solving for A is called a possible equation. As in, it's not 100% complete, but it's pretty close. So we're going to do that again with this next question. A reminder before we leave this one is that you should know that your W's are positive degree 1, 2, 3, 4. So this did not ask you to put it into standard form. That means that you can leave it all brackety, for lack of a better phrase. You do not have to FOIL all this out and make it look different. So let's take a look at this one and do exactly the same thing. So I'm going to look for my X-intercepts first of all, and then I will go looking for my Y-intercept. So X-intercepts, -1, 0, 3. All of them order 1. That means we have 1, 2, 3, a degree 3 is an n, we're okay. And there's my y-intercept, nothing to do with order. So a possible equation is f at x equals x plus 1, x plus or minus 0, x minus 3. So to make this look a little bit better, I'm going to pull my x forward and have my other two brackets behind it because that looks way more normal. No typos. You can or cannot put the a in. It's totally up to you. For the possible equation, we're just looking for an equation. But in order to continue into exact equation, which we're going to use the y-intercept for, you're going to have to put the a value in. Now, there's something to be said about this y-intercept, and that is, I've kind of already used it. So we need another point. So something other than the y-intercept. So you got to find, I'm going to call it a, and I'm using air quotes here, even though you can't see me, pretty point. So you have to go looking for something that you deem exact. Now, what I will do on a test or quiz or something like that, where I specifically ask you for an exact equation, I will designate a point. I'm not going to tell you the coordinates, but I'll like darken it up so that you can see it very blatantly. So we're going to use that one as our other point, and that's 2 across in the positive direction on the x, and then 1, 2, 3, 4, 5, 6, so -6. So we're going to use this in for the x and this in for the y, which is not as ideal as the y-intercept. The y-intercept is awesome because one of the numbers is a 0, and that's a pretty big deal. Remember that f at x is a fancy way of saying y. Need the a, turn the x into a 2, turn the other x into a 2, turn the other x into a 2. And I'm noticing a pattern here that is not always true. The pattern I'm noticing is we're getting another a is 1. And that is not always the case. Sometimes your a is 5, and then you'll insert a 5 back there. Sometimes your a is -7, and you'll put a -7 in there. Sometimes your a is some hideous looking fraction like negative 47 over 23, in which case you'd put negative 47 over 23 in here. Whatever the a value turns out to be, you plunk it in. Unless it's a 1, and then you have a choice about whether you want to make it visible or invisible. All right, so fingers crossed. Betcha this is another one of those ones. Oh well. All right, so X-intercepts. X-intercept, X-intercept, X-intercept. I'm not really sure. So is there another pretty point? I don't know what that is, and that's okay. It just means we have a little bit extra work, but it's BEDMAS, and BEDMAS shouldn't stress you out. So although I don't think it's exact, let's go with this one. I mean, at least it's hard or easy, or I guess you can't screw this up very badly because you're turning your x and y into 2's. But before you do that, let's discuss these x-intercepts. So we have a 1, we have a 3, and we have a 4. Now that means degree 3, but we have a w, so that's a degree 4. So something weird has to be happening here. And it's this. There's your bounce. We haven't had a bounce yet. We haven't had a squiggle yet. It could be the case where you have one of those. So I'm going to take this and I'm going to make it an order 2 because it's got the bounce to it. This is an order 1. This is an order 1, and 2 plus 1 plus 1 is 4, so that makes a degree 4. So we're all good. Possible equation. Y equals a for kicks, x minus 1, x minus 3, x minus 4, order 1, order 1, order 2. So now I'm going to take my 2, 2, 2, 2, haha, and I'm going to put it in for all the values. So 2 in for y, 2 in for x. Oh, I think it's going to happen again. So 1 squared is 1 times 2 is 2. Damn. I reversed it. Not a big deal. As in, I flipped this over. So what I will do, I'm going to leave my 1 invisible. What I will do is I'm going to shoot to this sheet, which is in your book. I'm going to have to clarify which page that is, but it'll be written on the Google site. Let's take a look at this question, only because you might have done something like this in grade 11 only with quadratics, and I'm drawing your attention to the fact that this is an equation, which means you don't have f at x anymore because it doesn't say function, and you won't have y anymore. You'll have equals 0. So I think that I have it. There it is. So I'm going to pull this in an opposite order. I'm going to put this here, and let's discuss the question. So based on the last questions, which were polynomial functions, you should have minimal problems figuring out what bracket 3 comes from and what bracket -3 comes from and what bracket 1 comes from as far as the roots go. But can we figure out where -1/2 comes from? Because I have this feeling that a bunch of you are going to want to do this, and although that's mathematically correct, it's ugly. So I want to do something prettier. So I'm going to talk through these over here in space for a second. So x equals 3, and we've done this before slightly. That means taking the 3 back across the equal sign and playing a little bit of Jeopardy, which is how you get that. And then if you have x equals -3, that means taking the -3 back across the equal sign and playing Jeopardy, and that's how you end up with this. And then finally, x equals -1 means taking the -1 back across the equal sign to play Jeopardy, and you end up with a typo. And you end up with that bracket. So what happens with this? Now, of course, you can take -1/2 across the equal sign and end up with x plus 1/2. But what really happened here? What really happened is you divided both sides by 2. So you originally had this. And then, playing Jeopardy, you move the 1 back, and you end up with a much prettier looking bracket. And if you disagree with me, that means you like fractions, and I know better than that. If you even answer like this, I can't give you full marks, and the reason for that is because you didn't give me a polynomial equation here, you gave me a polynomial expression. So in order to finish this off, you need the equal 0. Now, in addition to that, I'm going to spend a minute or two taking this stuff and I'm going to FOIL it out. So I'm going to make this in standard form rather than factored form, just for fun and to practice my foiling and to show you that there are some places that you can cut down on your work, and so that I can go on to the next stuff, which may or may not have been done in grade 11. So the first thing I recognize is that this is a difference of squares, or the answer to a difference of squares. So that right there could have come from x squared minus 9. Now, if I FOIL x times x, that's x squared. X times 3 is positive 3x. Negative 3 times x is negative 3x. Negative 3 times positive 3 is negative 9. Now, why did I do that before the other stuff? Well, because I think it's easier. Now I can FOIL out this, which there's really no huge shortcut for. So 2x times x, 2x squared, 2x times negative 1, 1 times x, 1 times negative 1, still equals 0. And then I'm going to collect like terms here. Don't know why I put that 1 in for the 1x, but I did. And then I can continue to FOIL. Oops, don't know what I did there. So 2x squared times x squared is 2x to the 4th. 2x squared times negative 9, negative 18x squared. Negative 1x times x squared is negative 1x cubed. Negative 1x times negative 9 is positive 9x. Negative 1 times x squared is negative 1x squared. Negative 1 times negative 9 is positive 9 equals 0. Just to double check, I've got 3 terms multiplied by 2 terms, which means I should end up with 1, 2, 3, 4, 5, 6 terms before I collect like terms. So I've got 2x to the 4th no other x to the fourths, minus 1x to the 3, no other x to the 3's. There's my x squareds. That's negative 19 of them. Plus 9, because I've got no other numbers, equals 0 to make me a polynomial equation. Now, as I said off the top, this is factored form, this is standard form. If you are not specified, would you not just leave it? And the answer is, of course, because we're all intrinsically lazy. All right, so next question. Not this. This was just explaining why it was an equation, or the difference between an equation, expression, etc. Let's take a look at this nasty one. Now, I'm kind of hoping that you don't find the first bracket all that nasty. But the second bracket is pretty darn ugly. Actually, it's second and third, because we've got 3 plus 2 root 5 over 2, and 3 minus 2 root 5 over 2. So that over 2 is the same thing as the over 2 here. So I know that it's going to pop up with the x, and I realize that's not very mathy. So I'm going to put 2x, and then I'm going to deal with this one. So it's going to be negative 3, because the sign switches, and also negative 2 root 5. Then the next one, the 2 is going to pop up, and it'll be negative 3 plus 2 root 5 equals 0. Now, you cannot leave it like this, so I'm going to FOIL. So my recommendation, don't know why I did that, my recommendation is that you FOIL this first, because good things are going to happen. So I'm going to leave my x minus, or x plus 1 that's not really useful to me. I'm going to leave my x plus 1 sitting out front for the time being. Now, watch me FOIL this. So it's 3 pieces of information multiplied by 3 pieces of information. So that means we're going to have 9 pieces of information. 2x times 2x. 2x times negative 3. 2x times 2 root 5. Negative 3 times 2x. Negative 3 times negative 3. Whew. Negative 3 times 2 root 5. Negative 2 root 5 times 2 x. Negative 2 root 5 times negative 3. Sorry for spacing. Negative 2 root 5 times positive 2 root 5 is negative 2 times 2 root 5 times 5. Now, that's pretty ugly, except for the fact that here's a negative 6 root 5, and here's a positive 6 root 5, and here's a positive 4x root 5, and here's a negative 4x root 5. And if that doesn't happen, you did something terribly wrong. Actually, it's probably not terribly wrong, just slightly. Everything else is okay, except this is super ugly. So I'm going to see if I can fix that as I do a little neatness recopy. So there's my x squared. Negative 6 and negative 6 is negative 12x plus 9 minus 4. And root 25 is 5. So that cleaned up nicely. And it should. So I'm showing a lot of steps here. And then finally, normal FOIL. X times 4x squared. X times negative 12x. X times negative 11. 1 times everything in that bracket. Negative 8x squared. Did you catch my typo? There is my polynomial equation in standard form. And I still don't have a very attractive 3. All right, one more. Ah! Eyes. Well, I guess the plus part is that there's no fraction with this one, but you'd know what to do with a fraction now. So x plus 2, the reverse of this. X minus 4 minus 3i, the reverse of both. X minus 4 plus 3i, minus the reverse of those. And again, FOIL the ugly first. So leave that x plus 2 for later, please. 3 times 3. 9 things arriving here. X squared minus 4x. X times x. X times negative 4. X times 3i. Negative 4 times x. Negative 4 times negative 4. Negative 4 times 3i. Negative 3i times x. Negative 3i times negative 4. Negative 3i times 3i. Double check, which I didn't do the last time, but 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, let's see if goodness happens. Oh, positive, negative. Positive, negative. Don't fake it. It should just happen. So negative 4x and negative 4x is negative 8x plus 16 minus 9. Do you know what to do with I-squareds? That's the question. Grade 11, I know COVID hit some of you, so I need to tell you right now that I-squared gets replaced with negative 1. So that's a thing. I can explain that to you in full if you wish. I won't explain it here. Please feel free to ask. I'm happy to. I just don't want to lengthen this video, and I don't know if you covered it or not. Almost done this question. My hand is cramping, but please recognize that, wow, I've gotten neater since my last few videos. At least I think I have. So normal FOIL. X cubed. X times x squared. X times negative 8x. X times 25. 2 times x squared. 2 times negative 8x. 2 times 25. 2 times 3 is 1, 2, 3, 4, 5, 6. So I haven't missed anything. Squared, squared, so that's negative 6 of them. X, x, that's positive 9 of them, and a 50. So that is your therefore statement for the polynomial equation. Now, take a look at this stuff. This had 4 roots. your answer was degree 1, 2, 3, 4. This had 3 roots. Your answer, degree 1, 2, 3. This had 1, 2, 3, 4 roots. 1, 2, 3, 4 degrees. This had 4 roots, but not for graphing purposes. You have 1, 2, 3, 4 brackets, and when you multiply it out, you've got an x to the 4th. Everything's fitting. Then when you get into the messy stuff, 1, 2, 3, 3 brackets, too hideous. Foil it all out, there's your x to the 3, and then finally 1, 2, 3, there's your 3 brackets, 2 of them hideous. There's your x to the 3. So everything should work out for you. Remember that when you go to the Google site, you should see what homework or what suggested questions are left for this. On your test, you will be asked, or assessment, you will be asked to work backwards and forwards. So this is considered backwards. This for me is Jeopardy, me giving you the graph or the answers and you providing the equation. There will be less of these than me providing the equation or the function and you providing the graph with all the work. So a little bit of both. So my opinion is to work on the sheet that looks like this. I will find the page reference, and I think I've put on all the arrows and clarified some of the numbers and maybe reminded you that these two things actually attach and that it's just a little bit of a typo. So that's that. Whoa, shorter than I thought.